My dear students, I welcome you to this new video. In earlier video, that is video number 494, I discussed the meaning and explanation of the Lorenz curve as well as the Gini coefficient. In this particular video, I am going to use some hypothetical data to measure income inequality using the Lorenz curve, and I'm using Excel. In the next video, I will use the same hypothetical data to calculate Gini coefficient or Gini index. So in order to do that, let me use some hypothetical data from Excel, and here is my hypothetical data. So this first column shows that there are only 8 people in particular area or in the world, and this column B shows the income of various individuals. So individual 1 earns 5,000 say weekly or daily, and individual 2 earns 8,000 rupees daily or weekly. Similarly, the 8th person is earning 55,000 in a week or in a day, and their cumulative or their total income, if we sum up their income, and that is equal to 1,98,000 rupees. In order to draw the Lorenz curve, I need the ranked population percentage on the basis of from lowest to highest income. So to do that, I'll use this formula. So 1 out of 8 is how much of and if I multiply this by 100, then it means that 1 out of 8 is 12.5%. So if I drag this down, this will give me the cumulative percentage share, and you see this is 100, so this is cumulative percentage share of the population. Now I'll also calculate the percentage of income earned by each individual, and in order to do that, I'll give this formula. So this is B3 cell divided by this is the total of income, and I will multiply this by 100. So this shows that 2.52% of the income is earned by individual 1, and if I drag this down, this will show that the second person income in the total income is 4.04%, and the share of income of the last individual, that is the 8th individual, is almost 28%. So there is a hell of difference between this percentage and this percentage. Now I would like to calculate the cumulative percentage income earned. So to do that, I'll give a formula, and I'll add this with this, and enter this gave me the same thing, because 0 plus this is the same, and if I drag it down, it will give me cumulative income in percentage form. Now in order to draw Lorenz curve, I'll press insert, and then I'll use the XY scatter. So I can use any of these, but let me select this one, and this I can make a little bit bigger, and so that we can see. After that, I'll select data, and from here I'll first of all I will draw perfect equality line. So for this, both the axes will be like this. This is the x-axis, and similarly the y-axis is also the same, so that this curve is having slope of 1. So after this, I got line of perfect equality. So it means that 20% of the population is earning 20% of the income. 40% of the population is earning 40%, and 100% of the population is then earning 100% of the population. So this is the line of perfect equality. And in this case, the value of Gini coefficient will be equal to 0. Now, in order to draw Lorenz curve, I'll select data again, and I will write now Lorenz curve. My x-axis is the same as before, but this time my y should be the cumulative percentage of income. So it's like this. I will select this, and after that I'll press OK, and after this okay, I made a mistake, so let me do it again. This is a Lorenz curve. Where is the Lorenz curve? Let me do it again. Let me do it again. So this is the line of perfect equality. So for perfect equality, I must write perfect equality, and for perfect equality, my x-axis is this. Sorry, this. And my y-axis should also be the same. So here is my. Now I'll first delete this Lorenz, and I'll add another Lorenz curve, and for x-axis, my x-axis should be the same. And my y should be this. So my dear student, you can see this blue line, this solid blue line is the line of perfect equality, and this orange color curve, this is increasing at an exponential rate. This is a Lorenz curve. Let me make it a little bit good visibly. So I would like to format the axis. So this should be 100, and this should also be 100. So axis, so the maximum should be 100 rather than 120. So now we have a Lorenz curve. Now this is the Lorenz curve. So the closer the Lorenz curve to the perfect equality line, the lower the income inequality. The farther the Lorenz curve from the line of perfect equality, the greater the inequality, or the higher the income inequality. In case the Lorenz curve is this one, then everybody gets equal percentage in the total income, and in that case Gini coefficient is equal to 0. In case Gini coefficient is equal to 1, then the last person gets the entire income, and the rest of the people they get nothing. Let us suppose now I make some changes in this. Let us suppose this is 500, 5, and this is 6,000. This is 6,500. This is 7,000. This is 7,500, and this is say 800, and this is 800, 8500. So you can see now the Lorenz curve came closer to the line of perfect equality. Similarly, if I do like this, this is 1000, and this is again 11,000, and this is 11,500, this is 12,000, and this is 12,500, and this is 12,800, this is 13,000, and this is say 80,000. Now you can see what happened to the Lorenz curve. So this is how we can draw Lorenz curve from data. And if I make all of them equal to each other, say this is this is 1000, and this is 1000, and this is 1000, and all of them are 1000, then in that case the Lorenz curve will overlap the line of perfect equality. So let us see. Yeah, now the Lorenz curve is perfectly overlapping the line of perfect equality. So my dear students, this is how we can compute or draw Lorenz curve from hypothetical data. You can have many observations, but this is the way how we can do that. So you must keep in mind that the x-axis is showing the ranked population from lowest to highest income, and the vertical axis, the y-axis, shows the share of income in the income earned by the individuals. So for that we need a cumulative percentage of the population ranked from lowest to highest income, and we also need to compute cumulative income share, and that is this. So that gives us then Lorenz curve. So let me show it again once so that you can see. This is say 1200, and this is 1400, and this is 1600, this is 1790, and this is 19, this is say for example 25, and this is say 28. So this is how we can play with the Lorenz curve. How can we draw that? So I hope this was quite interesting and useful for you. Thanks for watching this video. If you haven't subscribed to the channel, kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get timely notification about my other videos that I'll upload for you. Especially the next video will be on how to compute a Gini coefficient or Gini index from the same data that from which I drew this Lorenz curve. So kindly share various videos of this channel with your friends, with your